Good morning, students. Let's continue the chapter Thermal Properties of Matter. In previous lecture, we have seen heat transfer and the modes of heat transfer. There are three different modes of heat transfer. They are conduction, convection, and radiation. We have seen in detail the mode of heat transfer which is known as conduction, and in this lecture we are going to study the convection and radiation in detail. First, let us see what is convection. I have already stated that the heat is transferred in case of fluid, water fluid, the liquid and gases, they are fluids. The difference in solid and fluid is this, that in fluid the constituent molecules are loosely bound to one another, and as they are loosely bound to one another they are capable of flowing. So the liquid and gases, they are known as the fluids. Now let us consider a simple case of water which is filled in a pot. Suppose in this pot we fill water. This is the water in this pot. Initially, let us consider the temperature of water in this pot is T and the density is low. The temperature and density of water in all part is initially same, and that is T, and the density is rho. Now let us consider we are having an burnel. With the help of this burnel we provide heat to the water in this pot. The heat is first received by these molecules which are at the bottom, which are close to this flame. These molecules, they receive heat. Now let us consider this molecule A. When this molecule receive heat, its temperature is increased. When its temperature is increased, it starts vibrating with large amplitude, and that's why the density of this molecule A is fallen. The density is get decreased. The molecule, suppose this is the molecule which is present at the top. That molecule is denser as compared to this molecule because this molecule receive heat, and as it receive heat it vibrate with large amplitude, and as it vibrate with large amplitude its density rho decreases, and so this lesser density molecule that moves to the top, and that is replaced by this molecule B. Now this molecule B came to the bottom. Now when this molecule B came to the bottom, it received the heat, and when it received heat, again same thing is happen for this molecule. Its density rho that decreases, and as its density rho decreases it move to the upper side, to the top. This process of moving this water molecule in this pot is occur continuously, and the movement of this water in this pot is known as the convection current. Due to this convection current, the temperature of the water in this pot is increases. Such process in which the temperature increase is known as convection. In this, there is actual bodily movement of molecules. Now, let us see the definition of convection. What is convection? What is convection? It is mode of transfer of heat. So, in this also, heat is transferred from one point to another. Let us see the definition of convection. Heat is transferred from one point to another. It is transferred from one point to another by actual bodily movement, by actual bodily movement of the heated molecules, of the heated molecules where within the fluid. This is definition of convection. What is convection? Convection is a mode of heat transfer. In convection, heat is transferred from one point to another. Heat is transferred from one point to another by actual bodily movement of heated molecule within the fluid. So, this is the convection. In liquid and gases, the heat is transferred by convection. And now let us see the applications of convection. First application, heating and cooling of rooms. Heating and cooling of rooms. Now, it is our experience that in winter the temperature is fallen, and in summer the temperature rises. So, in winter we require to heat the rooms, and for that we are having the heater. Suppose this is the heater which is present in a room. This is room. Now initially, before switching on this heater, the air in this room is cold. Naturally, the cold air is having some higher density. Now when this heater is on, then the air which is near to this heater that receive the heat, and when this air receive the heat, then this air is having some excess temperature. Suppose this is molecule A. The temperature of this molecule is get increased. When its temperature increase, then its density decreases. Now this molecule is having lower density. This molecule which is having lower density that move in upward direction, and its position is replaced by the molecule. Suppose this molecule is denser because it is cold, and this molecule moved to toward bottom. Then again it receive heat, then again its density increases, then again it move in upward direction, then again the molecule which is present in the upper portion, which is having some more density, that fallen, and that replaces this higher density molecule. This go on continuing, and in this way the convection current is set, and due to this convection current the room is get heated in winter. Exactly opposite is happen in summer. In summer the temperature of air is high. Suppose this is the room and these are the air molecule. Its temperature is high in summer, and as its temperature is high, its density is low. We are having AC. Suppose this is our AC. This AC provide the flow of cold air within the room. The cold air is entered in the room. As this air is cold, its density is higher, and so this air moved in downward direction. This denser air moved in downward direction. The hot air moved in upward direction. This process is get continued, and in this the convectional current is set. In this way the room is get cooled with the help of this AC. So this is first application of convection, heating and cooling of room. Now let us see the second application, cooling of transformer. Cooling of transformer. What is transformer? Transformer is a device which step up or step down the voltage. In transformer there are coils. They are known as the primary coil and the secondary coil. When electric current passes through this coil, these coils are get heated, and if this current passes for large interval of time, then the temperature of this coil that get increased. We need to cool down these coils, and for this purpose we are having the transformer oil within this transformer. This is the transformer oil. When electric current passes through the coils are get heated, and the transformer oil which is close to these coils that get heated, its temperature increases, and as I have already discussed in above case, the hot oil that moved in upward direction, it is replaced by the cold oil. These transformers they are having the cooling tubes. These are the cooling tubes of the transformer. These cooling tubes increases the effective area of this transformer. Now this hot oil is in these cooling tubes. These cooling tubes are filled by this hot oil, and these cooling tubes, they are in contact with the air, with the surrounding air, and these cooling tubes, they transfer heat to the surrounding. This transformer oil is get cooled and it is moved towards the transformer coil again. This cycle repeat again and again. In this way, the oil, the coils of the transformer, they are get cooled. So these are the applications of convection. And now let us see the third mode of heat transformer, that is known as radiation. As I have already discussed, the radiation, in radiation, the heat is transferred in the form of electromagnetic waves. The sun that radiates the electromagnetic waves, and these electromagnetic waves reach to earth and we receive heat from sun by the process of radiation. The bodies which are hot, let us consider this is body A. The temperature of this body is increased. When this body become hot, when this body become hot, then the molecules within this body, they receive heat, and as they receive heat, they start vibrating with large amplitude. They are having maximum kinetic energies. Their kinetic energies are increased. And when the kinetic energy of these molecules of this hot body is increased, then they radiate the electromagnetic waves, or they lose their energy in the form of electromagnetic waves. These electromagnetic waves, they travel in space, and when these electromagnetic waves, they are again incident on a body, then they transfer their energy to this body. So this body is get heated. These electromagnetic waves are not require any material medium for their propagation. These electromagnetic waves, they can travel even in vacuum. So in this way, the process of heat transfer is carried. Now let us see the definition of this radiation. The radiation is defined as the transfer of heat energy from one point to another point. What is radiation? Radiation is again the transfer of heat energy from where to where? From one point to another via emission of electromagnetic waves, via emission of electromagnetic waves or electromagnetic energy. Without heating, without heating the intervening medium, without heating the intervening medium is called radiation, is called radiation. So what is radiation? Radiation is the transfer of heat energy from one point to another via emission of electromagnetic energy without heating the intervening medium is called the radiation. Now let us see the last part of this chapter, and that is the Newton's law of cooling. Newton's law of cooling. When a hot cup of tea is placed on table, then after some time the temperature of that tea is go on decreasing, and after sufficient time interval the temperature of the tea and the temperature of surrounding become constant. This is systematically studied by Newton in his experiment. He was having a calorimeter. What is calorimeter? Calorimeter is a copper vessel. Suppose this is the calorimeter. Now this calorimeter is filled about its 2/3 portion by the hot liquid, suppose by water, and suppose the temperature of hot water is T1 and the temperature of surrounding is T2 or T0. T2 or T0 be the surrounding temperature. We are having a thermometer and a stopwatch to measure the temperature of this water and to measure the time interval. Now suppose initially when this experiment is started, the temperature, when initially the experiment is started, the time is 0, and uh, and when and suppose at that time the temperature is T1. Initially the time is 0 and the temperature at that time is suppose T1 degree Celsius. After every minute we record the temperature after time interval 1 minute, 2 minute, 3 minute, 4 minute, we record the corresponding temperature. Suppose these are the corresponding temperatures. What we have observed that when time increases, the temperature of this water go on decreasing. If we plot a graph of temperature against time, this is the temperature against time, temperature T against time, then the graph is look like this. This is the curve. This curve indicates that initially for this time interval, this much time interval, the fall of temperature is this much. Initially, the temperature fall rapidly, and as time increases, the rate of fall of temperature that go on decreasing. And when the temperature of the hot water become equal to the temperature of surrounding, then the temperature become constant. If we draw tangent to this curve, what is tangent? Tangent is a line which touches the curve. Suppose this is the point A. At this point A, suppose temperature is T1 degree Celsius. Temperature is T1 degree Celsius. Then the slope of this tangent is dt1 divided by dt. dt1, the time axis, y-axis. On y-axis there is temperature, and on x-axis there is time. So this is the rate of cooling at temperature T1, and now we are interested to find the rate of cooling at temperature T2. Suppose this is the temperature, this is the point B, and we are interested to find the temperature at this temperature. For this, again what we do? We again draw a tangent passing through this point B. Then the slope of tangent is dt2 divided by dt. This is the rate of cooling at temperature T2. This is the rate of cooling at temperature T1. If we draw a graph of rate of cooling, what is the rate of cooling? dt by dt. If we draw a graph of rate of cooling against temperature axis, what is temperature axis? The temperature at that instant minus the temperature of the surrounding, that is the temperature axis. Then the graph is a straight line passing through origin. This graph tells that when the temperature difference between temperature of the body and temperature of the surrounding, this T1 minus T0, is 0, then the rate of cooling is also 0. When temperature of that water is increased, it is higher than the temperature of the surrounding, then the rate of cooling is increased. Then the rate of cooling is increased, and from this we can draw conclusion which is given by Newton. Newton concluded that this rate of cooling dt by dt is directly proportional to temperature excess or the temperature difference between the temperature of body, this T1 is the temperature of body, and the temperature of surrounding, this T0 is the temperature of surrounding. If that body is having excess temperature than that of surrounding, then the rate of cooling is higher. And if this temperature difference is decreased, then the rate of cooling is also get decrease. We can write dt by dt is equal to C into T minus T0, and from this we can state Newton's law of cooling. Newton's law of cooling states that the rate of loss of heat means this dt by dt is directly proportional to the temperature difference, this T minus T0. What is this temperature difference? The temperature difference, the temperature of a body and the temperature of the surrounding, provided that the difference in temperature is small. Now let us see Newton's law of cooling. The rate of loss of heat. What is the rate of loss of heat? dt by dt. The rate of loss of heat of a body is directly proportional is directly proportional to the difference of temperature, to the difference of temperature T minus T0 of the body. What is T? That is temperature of the body and the surrounding, provided that the difference in temperature is small, provided that the difference in temperature is small. So this is about the Newton's law of cooling. What we are having in this Newton's law of cooling? We are having the calorimeter. This calorimeter is having lead, and through this lead we immerse and thermometer which record the temperature, and at the same time with the help of stopwatch we measure the time. So this is all about Newton's law of cooling. Thank you.